Uh, Good morning. Today we will start with the next chapter, that is alternate fuels. We will start with the introduction. In this century, it is believed that crude oil and petroleum products will become very rare and costly. Day-to-day fuel economy of engines is getting improved and will continue to improve. However, enormous increase in number of vehicles has started dictating the demand for fuel. Gasoline and diesel will become rare and most commonly in near future. With increased use and the depletion of fossil fuels, alternative fuel technology will become more common in coming decades. So in the future we will use alternative. We'll find alternative for fuel like petrol, diesel. All these years there have been some internal combustion engine fueled with non-gasoline or diesel oil fuels. However, their numbers have been relatively very small because of high cost of petroleum products. Some developing countries are trying to use alternative fuels for their vehicles. Another reason motivating the development of alternative fuels for internal combustion engine is the concern over the emission problem of gasoline and diesel engines. Combined with other air polluting systems, the large number of automobiles is a major contributor to the air quality problem of the world. Quite a lot of improvements have been made in reducing emissions from automobile engines. If a 35% improvement made over a period of years, it is also noted that during the same time period, number of automobiles in the world increased by 40%. Thereby, the fact is nullified. Lot of efforts has gone into for achieving the net improvement in cleaning up automobile exhaust. However, more improvements are needed to bring down the ever increasing air pollution due to automobile population. A third reason for alternative fuel development is the fact that a large percentage of crude oil must be imported from other countries which control the large oil field. As of many alternate fuels have been used in limited quantities in automobiles, quite often fleet vehicles have been used for testing, taxis, delivery vans, utility company trucks. This paves way for comparison with similar gasoline fueled vehicles and simplifies fueling of these vehicles. The engine used for alternative fuels are modified engines which were originally designed for gasoline fueling. They are therefore not the optimum design for other fuels. Only when extensive research and development is done over a period of years, maximum performance and efficiency can be realized from these engines. However, the research and development is difficult to justify until the fuels are accepted as viable for large number of engines. Some diesel engines have started appearing on the market. They use methanol or natural gas and a small amount of diesel fuel that is injected at the proper time to ignite both fuels. Most alternative fuels are very costly at present since the quantity used is very small. Many of these fuels will cost much less if the amount of their usage gets to the same order of magnitude as gasoline. The cost for manufacturing, distribution and marketing would be less. Another problem with alternative fuel is the lack of distribution points, service stations where the fuel is available to the public. The public will be reluctant to purchase an automobile unless there is a large scale network of service stations available where fuel for the automobile can be purchased. On the other hand, it is difficult to justify building a network of these service stations until there are enough automobiles to make them profitable. Some cities have started a few distribution points for some of these fuels like propane, natural gas, LPG and methanol. The transfer from one major fuel type to another will be a slow, costly and sometimes painful process. In the following session, we will discuss the various alternative fuels. So possible alternative fuels are solid, liquid and gaseous in three forms. Present day automobiles use mainly liquid fuels for petroleum origin. However, some use gaseous fuel like compressed natural gas and liquefied petroleum gas. It is interesting to note that during early days, even solid fuels like coal, slurry and charcoal have been tried. In the following section, the various alternative fuels for internal combustion engines are discussed in detail. Table 6.1 gives the properties of various fuels. So you can see here this table. So you can check this table from the book also. You can see here gasoline, light diesel, heavy diesel, natural gas, then pure hydrocarbons include methane, propane, isoctane, cetane, benzene, toluene, and in coals we have methanol, ethanol, and other fuels like carbon, carbon monoxide, and hydrogen. So these are fuels given along with their molecular weight, their density, and their power output. You can see here their higher value of power, that is 47, 44 and so on, you can see, and along with other properties you can check this table. Now we come to the solid fuels. Solid fuels are obsolete for IC engines. In other words, in order to have historical perspective, some of earlier attempts are described in this section. In the later half of 1800, before petroleum-based fuels were perfected, many other fuels were tested and used in internal combustion engine. When Rudolf Diesel was developing his engine, one of the fuel he used was a coal dust mixed with water. Fine particles of coal were dispersed in water and injected and burned in early diesel engines. Although this never became a common fuel, a number of experimental engines using this fuel have been built over the last 100 years. Even today, some work continues on this fuel technology. The major improvement in this type of fuel has been reduction of average coal particle size. In 1894, the average particle size was 100 micron, and nowadays we use even 10 micron. In early 90s. The typical slurry is about 50% coal and 50% water by mass. One major problem with this fuel is the abrasiveness of the solid particles, which manifests itself in bore injectors and piston rings. Coal is an alternative fuel because of the availability in large quantity. However, as an engine fuel, other methods of use seem more feasible. These include liquefaction or gasification of coal. In late 1930s and 1940s, petroleum products become very scarce. Rare due to the World War II. Just above all, gasoline products were used by German army, leaving no fuel for civilian automobile use. And although this was an inconvenience for the civilian population, it did not stop them for using their beloved automobiles. Enterprising people in several countries, mainly Sweden and Germany, developed a way to operate their automobiles using solid fuels like charcoal, wood and coal. Next to your liquid fuels. Liquid fuels are preferred for internal combustion engine because they are easy to store and have reasonably good calorific value. In the liquid fuel category, the main alternative is alcohol. Alcohols are an alternative fuel because they can be obtained from both natural and manufactured sources. Methanol, methyl alcohol and ethyl alcohol are two kinds of alcohol that seem most promising. The advantages of liquid fuels are as here. It can be obtained from number of sources, both natural and manufactured. It has high octane fuel with anti-knock index over 100. Engines using high octane fuel can run more efficiently by using higher compression ratios. Because octane number is higher, you can use higher compression ratio as compared to spark ignition engines. The coals have higher flame speed also. It means there is a lesser time for the combustion of the fuel. It produces less overall emissions compared to gasoline. When coals are burned, it forms more moles of exhaust gas, which gives a higher pressure ratio and more power in the expansion stroke. Because when the coal burns, the number of moles, as we discussed, the pressure produced and the mean effective pressure is proportional to number of moles and temperature in cylinder. So the more number of moles in the exhaust gases. It has high rate of heat of vaporization, which results in a cooler intake process. This raises the volumetric efficiency of engine and reduces the required work input in the compression stroke. Alcohols have low sulfur content in the fuel, so this will also reduce the corrosion in the engine. The disadvantage of alcohol as a fuel are, what are the disadvantages? Alcohols have a low energy content, or in other words, the calorific value of alcohol fuel is almost half. You can see in table also, here you have alcohol, or you can see calorific value, it is almost 22, which is almost half of the gasoline engine. So we have to use twice as alcohol to get the same power output. So this means that almost twice as much alcohol as gasoline must be burned to give the same energy input to the engine. With equal thermal efficiency and similar engine output uses, twice as much fuel would have to be purchased, and the distance which could be driven by the given fuel tank would become half. Automobiles as well as distribution stations would require twice as much storage, twice the number of storage facilities, twice the volume of storage at service station, twice as many trucks and pipelines. Even with the lower energy content of alcohol, engine power for the given displacement would be about the same. The reason for this is because the lower air fuel ratio required by the alcohol. Because in the alcohol, if you check the formula, this is CH3OH, so we have oxygen within the fuel itself, so lesser amount of air is required, So alcohol contains oxygen and thus requires less air for stoichiometric combustion. More fuel can be burnt within the same amount of air. So you can inject more fuel into the cylinder, and at the same time you can produce more power. Combustion of alcohols produce more aldehydes in the exhaust. If as much alcohol fuel was consumed as gasoline, aldehyde emissions would be a serious exhaust problem. This is the drawback for the alcohol aldehyde productions, which are poisonous also. Alcohol is much more corrosive than gasoline on copper and brass and aluminum, rubber and many parts. This puts some restriction on the design and manufacturing of engine to be used with this fuel. Fuel lines and tanks, gaskets and even metal engine parts can deteriorate with long-term alcohol use, resulting in cracked fuel lines. The need for special fuel tanks, etc. Methanol is very corrosive on metals. It has poor cold weather starting characteristics due to low vapor pressure and evaporation. Alcohol-fueled engines generally have difficulty starting at temperature below 10 degrees Celsius. Often a small amount of gasoline is added to alcohol fuel, which greatly improves cold weather starting. However, the need to do greatly reduces the attractiveness of any alternative fuel. Alcohols have pure ignition characteristics in general. Alcohols have almost an invisible flame, which is also a problem, which is dangerous when handling a fuel. A small amount of gasoline removes this danger. So flame is invisible. It means when the it will burn, you can't see whether something is burning or not. So it is a very dangerous for when during the handling of the fuel. There is a danger of storage tank flammability due to low vapor pressure. Air can leak into storage tank and create a combustible mixture. So because the storage tank flammability due to low vapor pressure is very low, so the air can leak into the cylinder and it will further produce a you can say dangerous conditions for during storage. There will be less NOx emissions because of low flame temperatures. However, the resulting lower exhaust temperature take longer time to heat the catalytic converter to an efficiently operating temperature. This problem persists in the catalytic converter because catalytic converter operate at a high temperature, and for the rest of time when the temperature is low during the starting of the engine, so there will be you can say addition of the NOx, which is a pollutant to the environment, and this is a limitation. Many people find a strong odor of alcohol very offensive. Headache and dizziness have the experience when resulting in refueling an automobile. There is a possibility of vapor lock in the fuel delivery system also. So this is about the alcohol. In the next class we will discuss about the next fuel. Subscribe this channel, and for more videos comment in the below section. Thank you for watching this video.